What if I told you you could build a perfect curve? Not with a compass or any fancy tools, just a piece of paper, a bit of paper folding, and some curiosity. You don't need to know the names of any special points or lines yet, but by the end of this video, you will see the hidden magic that brings this curve to life. We start by placing an A4 piece of paper in a landscape orientation. Mark a point somewhere near the horizontal center of the paper. Label the point F. Now, fold the paper so that the bottom edge of the paper just touches this point. Create a crease along this fold. Now unfold the paper and use a pencil and either the paper fold or a ruler to mark a line along this fold. Now repeat this process for a range of different folds. Each fold requires the bottom of the page to touch point F. The end result should produce a net, a series of lines that reveal a curve. Now pause the video while you complete this task. Then watch part 2 to see how you can do all of this on your TI-Nspire calculator. Start a new document and insert a geometry application. Press P to create a point. Place a point close to the middle of the screen, just like you did on the piece of paper. When you're done, press Escape to release the point tool. From the menu, select Points and Lines and choose the Line tool. Place a point near the bottom left corner of the screen. Now hold down the Shift key and move to the right. Then click to create the line. From the menu, select Construction and choose Perpendicular Bisector. Click on the line followed by the point. Press Escape to release the Perpendicular Bisector tool. You can extend the bisection line in either or both directions. The final step in this construction is to track the perpendicular bisector. To achieve this, return to the menu, select Construction, followed by Locus. Click on the perpendicular bisector, followed by the point on the line. A web of lines appears. These are the same as the folded creases in the previous activity, but these are dynamic. Grab the point in the middle of the page and move it. Try grabbing the horizontal line. Once you're done, you'll need to insert a graphs application and repeat all of these steps, but place the original point at 0, 2 and the horizontal line at 0, -2. Once you've created your envelope, graph the quadratic equation y = x squared. Then see if you can transform that graph to make it fit nicely in the envelope. In our next activity, we explore the geometry behind this construction, learn the names of these points and lines, and how they relate to a parabola. That's all for this session. We'll catch you on the next video.